Da, 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 da. We can probably tell people that we're streaming. Okay, we are on. Looks like we're on Mixer, and on Facebook and YouTube, and the last one is Twitch. Let me tell people. Uh, okay. Um, okay. Cool. 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 Yeah. Welcome to people who have signed in and are seeing me stream. So the purpose of today's stream is to kind of kill time. Um, I wanted to actually work through like a data science workflow, just for fun, and also because it's going to be a lot different from the stuff I've been doing. So lately, I've been like doing a lot of job search stuff, and I kind of want to actually use this stream to actually look at a completely unknown data set and demonstrate like how I'd actually work through it. I guess I should start. My name's Aaron. I am a data scientist. I am currently on the job hunt, and I'm also a photographer. So yeah, I am pretty receptive to hearing all sorts of feedback or anything. If there's anything I can do to explain something, or even if you think I'm not doing something correctly, like just send me a message and I'll try to answer your question. Um, so yeah, yeah. So right now I'm calling this date with data, and the idea is like I'm gonna work on this for a few hours, and in the future, like maybe next week, I'll continue working on it, um, and just we're just gonna play around. In terms of where data sets are, if you've done any data science stuff, there's a couple names that are really familiar. So those are going to be data sets. Kaggle is a really big one. In fact, they actually run a bunch of like data science, machine learning competitions, and you can actually win money by doing those things. And let's see what else. There's other ones that I want to play with. So the U.S. government, they actually have like a data.gov, and it stores a bunch of government provided for free by the I think state federal government, and then individual states can have their own. So it depends on what kind of subject material you're looking for. Microsoft also has a good collection of data sets, like from all over the place. But I think for purposes of stream and today, I think I'm just going to go straight to Kaggle. Um, there's a couple of reasons why, like UCI, which is like a really famous data set. I think it's the one that actually provides the like very, very well known in the data and machine learning and that type of community, the Iris data set. Uh, that is cool. It's good to teach stuff on, but I'm not a huge fan of the UCI stuff just because the data is so clean that it's really unrealistic. Um, yeah, typically the like with with a lot of things, right? Like the things you get in affect the things you get out. So with data science in particular, if you've got a super clean data set, it's really easy to get good results out of it because there's less wrangling to do. Um, and UCI, because I believe it is an academic, let's actually look. UCI data sets. And I've got my Brave browser up here so we can actually see what I'm looking at. And let me move the chat window. Okay, so UCI, yeah, so UCI data machine learning right here. If we click through, yeah, also sorry, I'm like, I just got out of the shower after a hard workout and it's still like that, those like shower sweats where you've just showered and like you're still kind of like steaming from being in the bath and all that kind of stuff. Like that's what I'm going through right now. I'm sure it looks great on camera and definitely something I should address publicly. But yeah, if you look on here, UCI has a bunch of these data sets. The biggest one, where is it? Iris. So that's like a really famous one. Um, like, yeah, these are real data sets. They are very, very clean. I mean, I've used other things from here. I think during the boot camp, we actually used like a drug survey data set from here. And it was really nice to use that because we actually wanted a quick turnaround on that project. But in terms of like learning how to deal with stuff, I'd say start with these, but you can always go to something a little bit more complicated. The one that I usually that is actually really popular in a bunch of communities is this site called Kaggle. Um, Kaggle.com. All right. Well, it's loading. Yeah, I don't know if people are. I'd love to hear about if you're here, what kind of stuff you hope to see. Maybe we can get some suggestions for data sets we can play with, or just how your day's going. I can't really tell who's actually signed in right now, so yeah. um, but yeah. So right now we've got the blank Kaggle page here. Um, I might have to log in. I should have thought about that. I normally don't use Brave except for like browsing photography stuff. The reasoning is because I have Edge open on here, and it kind of accidentally opened. And since since I'm like looking for a bunch of stuff and trying to learn a bunch of stuff this time, there are entirely too many windows and tabs open. So I don't want to show Edge because it's just kind of a mess. So I decided like, well, let's just go with something simple. Go with Brave, which rarely has anything open for me. Um, and then for some reason, Edge opened and kind of messed up all those plans. But fine. If we go over here to datasets, we can see what stuff we can choose from. Um, so I actually, if you want to provide suggestions on data to look at, I actually do have some rules. So I will not do any coronavirus stuff, and I will not do any food stuff. The food stuff I'll explain first, and it's because I have a machine learning project where I'm actually playing with food. So I have seen some of the food data sets already, and it's kind of unfair to like show like, hey, like this is a data set I've never looked at before, and I've actually seen it. And I won't do coronavirus because I don't think it's a good idea for me to do that. I don't want to come across as an expert when I'm not an expert in public health. I personally would love to play with the data, but I'm a little worried about like spreading some sort of misinformation. And frankly, like maybe people want to take a break from all that bad news. So I'm gonna pick a different data set. Um, yeah, so if you look, like there's a whole bunch of different stuff that's on here. I actually wonder what would be a good COVID healthy diet. How is that? Okay. Um, what do we feel like doing? January flight delay prediction. That might be interesting. Fake and real news. There is so much stuff that is COVID related. um, um, let's see. We have got chest x-ray images. That would be pretty cool. So I don't have any experience doing any sort of image breakdown using data science. I have done image analysis before, but it was during my dissertation, and it was all like manual frame by frame stuff. So it was actually like a lot more complicated. Um, and I was trying to push for incorporating that stuff to be put into a much faster computer centered pipeline. But that ended up not happening as hard as I tried. Let's see. Wow, there's a huge amount of stuff here. So you can see, like, actually, I don't know if you can tell because the resolution's so low on the stream, but there's just it could be looked at. Let's see, like 190 bird species. That's probably a classifier where you just want to go through and say, like, here's a picture of bird. What bird is it? What else do we got? house sales in King County. This one's really popular. We had to use it for our data science bootcamp, and I think it shows up in a lot of different courses. Pokemon with stats. Okay, cool. Um, I'm actually pretty curious about this one. I started playing Pokemon Go in January, so it's definitely started my like Pokemon kind of kick again. And I'm kind of interested. Like my brother and I threw out the idea of like, what if we built like a machine learning thing that could build a team for you? So that would actually be really hard because if you don't know Pokemon very well, or depending on how you played Pokemon, if you're doing the kind of way that I think it was actually intended. It's a game about collecting and exploring, I think. But if you're playing on the PvP, it's way more complicated, and it takes the like rock paper scissors aspect of the battle and just sends it crazy through the ringer. So let's see. This dataset includes 721 Pokemon, including their number, name, first and second type, and basic stats. HP, attack, defense, special attack, special defense, and speed. And those are all of the stats. It's been a great use when teaching statistics to kids. With certain types, you can also give a geeky introduction to machine learning. Hey, so I think these are the raw attributes that are used for calculating how much an attack will do in the games. This data set is about the Pokemon games, not the cards or Pokemon Go. Okay, cool. The data types. Okay, so one of the reasons why I actually like using Kaggle as a data source is they actually uh, built into the oh, that's not good. Built into the website is typically if the data is like a JSON or a CSV, there's actually a thing to break down what the statistics and stuff of the data inside is. And I personally think this is actually really good because one of the hard things with dealing with data is when do you do a train and test split if you have to train a model on it? So in theory, the closer what I learned was that in theory, the closer you get to the raw actual data, the better. So in an ideal situation, you would take the data, the raw data, and then immediately split it to train and test because you basically don't want to have done anything to the to the test data. You just want to play with the training data. One thing though is that depending on the data set, that might affect how you're testing and training the model, I think. So one example I had in mind was if you have very imbalanced data sets. So let's say you're dealing with fraud. So you've got a bunch of credit card charges, and you have to determine whether or not a charge is fraud. And typically, those fraudulent charges are like a ridiculously low percentage of the actual charges for any sort of day or week or whatever. So you run into a problem where if you have such an imbalanced data set, if you sample the train and test data incorrectly, it could give you like an unrepresentative sample. Or like I noticed this more with my food data sets that I dealt with before. I had a couple recipes that basically like they only had, let's see, there were 18,000 recipes in my machine learning app, and there was only one for I think Vietnamese food, which is super weird. There's definitely more than one Vietnamese dish, and also only one for like South Korean dishes or something like that. So if I had done a train and test split, it would have likely missed those classifiers, and also those imbalanced data sets had like a way higher proportion of say American food or Italian food. So if I split it randomly, there's no guarantee that I would have had like even some of the less populated or less represented samples in the training set. So then when I run tests, it would try to identify something that like it has never seen before. So how I've tried to do things is do like a really, really rough sort of explanation, like top down exploration. I think I said exploration. Really like top down look at whatever the data is and see if like is there an imbalanced set. If it is, like, then you'd have to do what's called a stratified split, which basically tries to preserve the proportions of the train and test set into the similar, like, imbalanced proportions. So let's say you've got 1,000, let's say you've got like 10,000 whatever samples, and you've got like 100 of them are fraudulent. So if you end up with like all 100 in one set, that's a huge problem, because basically, like, you never know when something is fraudulent, right? So if you're to split that into your, like, say, a 70% training set and a 30% testing set, if you, like, yeah, so if you if you split into 70% train and 30% test, you can already see that 70% of the samples could easily encompass like the underrepresented imbalanced set. If you end up with stratified test, which would try to preserve everything, then at least of those 100, 70 would go into the train and 30 would go into the test, because it will also try to split, like, the keep all the proportions the same. Yeah, I believe that's right. Yeah, so what we've got when we look at the CSV is we've got the index number and the Pokedex, which looks flat as a histogram. Makes sense. There should only be like one for each number in the Pokedex. This is a little bit complicated because if it includes some of the newer generations, I think some of the newer ones, like the Alolans and the Galarian Pokemon, are under the same Pokedex number. So that might be why there's like not totally flat. And I think also these bins are not split evenly. So we'll just, yeah, I don't think those are split evenly. That's fine. We'll worry about that later. And in here, the next column is name, it looks like. So we've got Bulbasaur, which is the name of the Pokemon, and then 800 unique values for Pokemon names. And then type, there should be 13 types, if I remember right. So, or 16. Okay, well, it's just how much I remember. Oh, yeah, first type, second type. Let's see. This is interesting. Oh, yeah, that's right. Okay, so this might be a problem when we actually open the CSV. We've got, whoops, not every Pokemon has two types. So of course the second type can have null. So this is going to actually represent something that we have to deal with when we actually use the data, because null in the data, like, one question that has shown up in a lot of problems I've seen, whether for the bootcamp or just on my own independent projects or even some take-home challenges. Basically, one simple question is how do you deal with null, and it depends. Let's see, this one of attack. Okay, so the sum total of all the, I guess, base stats of the Pokemon, and for each Pokemon, I would assume. Yeah, because it goes up to 780, and then number of hit points. Okay, let's see, what other columns do we got? The hit points, attack, so values of the individual stats. So those should sum up to this column here. And if they don't, we already know that there's a problem with the data. And the last column looks like it is a Boolean if the Pokemon is, whether or not the Pokemon is legendary. That's kind of funny. So it says true if the Pokemon is legendary, and then false if it is not, and then revise based on whether there's a difference between mythical and legendary. That's kind of funny because I personally find that to be very confusing in the game right now. It's like, what makes a mythical Pokemon special versus what makes a legendary Pokemon special. So yeah, okay, cool. I think this would be kind of fun to play with. Is there an end goal for this data set? So some of these Kaggle sets, notably the challenges, which I guess would be under compete. Let's open that up. Oh, and then we also have this bird species. So it is a data set of 190 bird species, a bunch of images, train images, 26,000 we'll say, and then about 1,000 test images, 5 images per species, and then about 1,000 validation. So let's see, all images are pretty low resolution and RGB, so red, green, blue, and then a consolidated blah, 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 images. So yeah, this is kind of what I expected it to be. This is you look at the picture and you try to classify what it is. So given that you have 190 species, what you're going to try to do with this one is build a model that will train on the near 26,000 images and then try to identify, like, with your test, how good your model is at identifying of those 190 and then moving on to the validation. So train, test, validation, kind of different. So validation is a set that you're supposed to keep like completely separate from all of your model stuff. So the idea is like you can train on training set, test with the test set, but you may actually like iterate on the model and reuse the test set. What ends up happening is if you do that, you end up essentially training on test, which is not great. So validation is like a set of data that is supposed to be completely separate and is never really supposed to be used until you think that your model is good enough. Yeah, so I have not had a lot of experience doing the things that require validation set. Most of the stuff I've used, like I've had training and I've had tests, and then most of the time the data sets I've used have frankly not been large enough to justify like splitting it further. My food data set, for example, just straight up did not have enough recipes in it. If I had to split again to preserve the classification, I would have huge problems because there just wasn't like I had so many underrepresented cuisine styles. So this would also be really cool and also give some experience with image recognition. So yeah, okay. Gonna guess that this is gonna be hard to download. 1 gig, okay. Versus 43 kilobytes for the Pokemon one. You know what? I think I actually want to try this bird species one, but that download of 1 gigabyte, even on my connection, would take a while. So I think I'm gonna download both and then kind of start with the Pokemon one. Let's see what the competitions were. So okay, cool. This, if you really like Kaggle and you want to boost your rankings, I've been told I should do this, is you can actually enter these competitions. And then if you are winning a competition, you can put that on your resume and stuff like, oh, I won a competition. And it kind of shows that like you are actually better than quite a few people at doing this kind of stuff. So one, the money looks like really good, but typically these teams, like there's 736 teams playing, and some people are just like really good at this, and they're just trying to get some scratch on the side. Yeah, and even this one for 50 grand, like use tensor performance units. Like this actually might exclude a bunch of people from entering, which may be why this is like so expensive or such a high reward. Yeah, and I mean, don't do these things, I think, to try to get money. I've seen some interviews that said like if you're trying to win money from Kaggle competitions, it's probably a losing battle because they sometimes some ringers just come in and do these things for fun. Generally with these things, I've been told that it's better to do it for the knowledge and skill set that you'll gain, and hopefully you do well enough that you can actually comment on, hey, I did like better than 50% of the people on here. Yeah, so Kaggle is a really good site. Let me see if I can download. I will probably have to sign in. Yeah, okay. I'm gonna hide this for a second and log in and then show it back again. So let's show Visual Studio Code. And we're gonna hide Kaggle for a second. Cool. So yeah, now I've got Visual Studio Code open while I sign in. keyboard underneath to make sure nobody can see. It is really hard to type. My under keyboard area is not much taller than the height of the keyboard. Okay. Oh crap! Did I forget my? I think I forgot my Kaggle password. That is annoying. I'm sorry about this, y'all. All right. I can do this. I'm gonna turn off my webcam. It'll be easier for me to type everything. Cool. But yeah, I'm still not sure how many people are signed on. I don't see any activity in the chat from y'all. Let me know how it's going. I know this is a lot different from my normal of doing like photo stuff, but I figured this would be fun. Love to teach people about this stuff, and like actually would love more to learn more about this stuff and just be better at this. There is always a chance to get better, whether it is coding, data science, photography, really anything. And I just like having that. Did I really I think I honestly forgot my Kaggle password. Okay. Sorry about this. Oh, hey, Christian. Thank you. Let's see if this, I don't think this will help much. I can shrink down a bunch of other stuff. All right. I should have gotten an email with the code. Sorry, I'm still moving around my windows for you too. Okay. Oh, that's why. Okay. And I'll get back on camera in a second. I just did not use the right login information. Yeah. Okay. And now I can't log in with my email. Yeah, sorry about this hold up, y'all. Okay, so we're still logging in so I can download a data set. Really sorry for the holdup, because I also cannot wait to try to play around with stuff in here. Did it log me in? Cool. All right. And I'm finding out that I'm actually technically a novice at Kaggle because I think I've only downloaded like 2 data sets from here. Humbling. But yes. Okay. So we'll do the species one, and we're going to download that one. Once we get back to here, it's going to take a while to load, and then make sure we're logged in to try to get the Pokemon one. we'll turn the streaming camera back on. Cool, cool. And then actually, well, okay, never mind. I was trying to plug in a light. Okay, cool. Let's see. Okay, we're gonna download this, and then the Pokemon one we logged in. We're also gonna download that. Okay, so just all right. So in the meantime, let me see if I can get term because we're gonna have to go into that in a second. Um, this is supposed to be terminal. It does not look like it's running. That's weird. Okay. Well, interesting. I can see terminal, and then it looks like it's broadcasting as a gray box. So let's not use that. But basically, what I'm going to do, since I have downloaded this data now, I'm going to go into terminal, and I'm going to make directories for all of these so that I can have them ready for projects later. Yeah. So in my root folder, and just FYI, I know you can't see it. If you don't, I guess OBS doesn't play nicely with the stream with this terminal. I'm in my root directory, and I actually use Windows Subsystem for Linux. So I'm on the insider build for Windows. I kind of like Linux, just in how it works. I was having some issues getting some stuff to work in Windows 10 for real. So I'm actually running Windows with Windows Ubuntu as my Linux distro. I have heard that there's some other ones that are better. I can't remember at the top of my head. Oh, Penguin I've heard is really good. Ubuntu has just seemed like the really solid, like safe choice, so that's kind of why I went with that one. So yeah, I'm gonna change into what directories do I have? Okay, so I'm gonna change into a directory that I've called coding. And I'm listing all the stuff I've got in there. So I'm going to change into a folder I have called projects. And what else do I have in here? So, oh, cool. So I'm kind of brainstorming ideas to write an article on using a GPU for training data sets, like different data sets. So machine learning stuff and just general sort of data science or machine learning problems. And the reason why is because I bought this. I don't know if you can see. You probably can. This giant box here on my desk is actually my external GPU, which is hooked up to my laptop. And I wanted to do some performance benchmarking to compare everything and see if it's actually worth it to use it. These benchmarks have shown up for gamers, but I haven't seen a whole lot of like easy to understand things with data scientists or machine learning engineers. I'm going to spoil that article a little bit, just as a practical thing without any sort of hard numbers or hard data to back it up. I don't really recommend getting an external GPU if you're trying to use it for data science projects. I will tell you that it took me like 2.5 months to get this thing working because it is really buggy. It is not all that fun to work with. It's like basically you can plug it in and plug it and unplug it, and sometimes it works and sometimes it doesn't. I think the bigger thing is when I leave this on for a while, I'd say like sometimes after like an hour and a half, it'll just crash. And obviously, if you've got like a huge set of data that you're trying to train the model on, that's not great, right? Because you're even with the horsepower behind a GPU, you're going to be training the model for a really long time. So if it crashes in the middle, that's like you've just wasted a bunch of time, right? So personally, I think if you have the money to actually buy like an external GPU with an enclosure, uh, it's probably better to just save up a little bit more and just build a separate desktop. And then you actually get the advantage of like building this separate machine, which will likely just run Linux to save you even more money. And then, which that kind of gives you like data engineering experience and data administration. And then you can also remote into the server, which I think is a lot more indicative of what happens in like real life or real companies. Because like, I don't know, I highly doubt anyone on the like any of the TensorFlow teams has like the actual thing on their compute on their little laptop, right? Because data sets you can work with are just way too big for any sort of real laptop. So yeah, that was a very short summary. I want to actually write the whole article with benchmarks saying like this is the type of performance you'll get, but still working on that. Yeah. And then the other project I'm working on is a Russian handwriting character recognition one, and that's collaboration. That's gonna be fun. Yeah. So anyway, I'm in this projects folder. I'm gonna make a directory. Let's say make a directory called Kaggle, right? I'm gonna put all the Kaggle projects in here. I'm gonna change into the Kaggle directory and make another one inside this Kaggle directory called Pokemon. And I'm gonna put the date on the end of it so I know when this happened, and it's from the stream. Today is April 29th. Wow, already. And I'll also make a directory for the bird set. So bird ID 2020, whoops, 2020 04 29. Okay, so let's see what we got. The Pokemon directory that we've got, if we open this up, the zip file Kaggle has one CSV. Oh, sorry, that is the Pokemon directory. And then for the one, say that having Visual Studio Code, terminal, and a bunch of web browsers and the streaming software, my computer like hates me right now. OBS claims that I'm using 30% of the CPU. I'm pretty sure that's wrong. I think that's just what OBS is using. I think the entire thing is like completely annihilated. So it is taking a little bit longer to load things. For example, I tried to open the bird species zip and it looks like it made Explorer crash. So we're going to go into the Pokemon directory. We're gonna and do this thing that like we're really not supposed to do, but I'm gonna like use the GUI to put all this stuff in because I actually forget the commands to unzip in the terminal, and plus I would have to move all this stuff over there. Okay, so we're gonna go in. I know where this directory is, but I'm going to put this Pokemon CSV into not there. It was not my folder. I'm in coding, then projects, and Kaggle, and Pokemon. I'm gonna paste this in here. Okay, cool. So if you can't tell, the terminal's not working. Okay, if we put that in there, then we've got a CSV in there. Whoops, CD. Okay. And what I'm going to do, since now I'm in the Pokemon Direct, because I would think it'd be good to actually put this on GitHub so that whatever changes and stuff we make can actually be good. And while I'm doing that, I'm going to touch a readme.md. And then the bird species finally unfroze and is working. Studio Code to open the README. And let's see if we can stream that too. And in terms of whatever like code editor you want to use, I prefer Visual Studio Code. I have used, let's say, I've used Vim and a couple other things. I just like it. Visual Studio Code. I think it's really easy to understand. It has a bunch of features that you can add on. It's like I don't know. Honestly, I think it's this one. Okay, cool. So we have got this open, and I probably have to change the window size in the stream. Yeah. Whoops. Sorry about that. Okay. Let me go ahead and fix this. Okay, so we've got Visual Studio Code open, and if you'll notice, code will actually display all the contents of the folder. So this is the CSV that came from Kaggle Pokemon, the Pokemon CSV, and this is the README that I created with Touch. So first things I'm going to do, I'm basically just going to start writing up some documentation. So it's basically like the README has some markdown language, and one of the things that's important is like this ampersand. Sorry, pound sign, Octothorpe. This basically denotes that this is going to be a header. So it's like, what is this project? I think maybe it's having some issues with the actual formatting, but I noticed this in a different project before where basically just like was not actually making these headers, but we'll deal with that later. So yeah, this repo is, let me actually move chat so I can possibly see all type. And OBS. Okay. Okay. So this repo is the initial date with data. Whoops. Oh, you know what? I'll make this bigger so that people can see. View. Let's zoom in some more. So one thing, I'm using Visual Studio Code now, but to do the exploratory data analysis, I think I'm actually going to swap into a Jupyter notebook. And the reason why is because we've got a CSV, I'm going to want to use pandas. And that will actually allow me to see it in like a spreadsheet sort of fashion and would be a little bit more powerful to play with. And then I can actually do like some exploratory data analysis. With the scripts or with Python and this MD stuff, like this is just for documenting stuff that I want to write down. And then with the notebook, I can actually make some visualizations. So if you don't have Python, I probably should have started all this with this disclaimer. I personally use Python and I use Anaconda. And the easiest way to get into any of these projects is to go to Anaconda and install the version for your operating system. So I'm going to open Brave again and just show you really quickly where you can actually get those things. And so let's turn to Brave. Sorry. Wish there was like an autofill this space. So I believe it's Anaconda. We're just gonna go to Google. Anaconda. Okay. Yeah, so the world's most popular data science platform. That is quite a brag. um, the reason why Anaconda is so good is that you can start with Python and just install the packages yourself, or you could realize that waste of time and just get everything all together, and then just get straight to playing with data. And I personally, I mean, I just kind of revealed where I'm feeling about this. Um, I think you should definitely just full on just get Anaconda and just make things a lot easier. One thing that is kind of tricky with this is Anaconda also comes with its own package manager called Conda. Not everything is Conda. So things like TensorFlow, when you start machine learning stuff, TensorFlow is in versions, I believe, on Anaconda. So it does take a little while. So basically, like the packages, all the libraries and stuff that people work on, they can submit to Anaconda and get that up to date. But it does go with the whole process. So on one hand, it's easier, but if you want like the really new stuff, then you'll have to use pip, which is part of Python already. Yeah, they have changed. Anaconda has changed the website since the last I've been on here. It looks a lot slicker, but you can kind of see like why it's such a useful thing. So all of these packages that they show here, so Jupyter, SciPy, I've never used Spider actually. Jupyter, SciPy, NumPy, Bokeh for plotting, scikit-learn for sure, Pandas, Matplotlib for visualizations, the Conda package manager. They say TensorFlow, but the last time I looked, their TensorFlow version was like 1.6, completely different. Let me check. It goes the actual website, so that's not. Anyway, that's a whole digression. If you want to do stuff like this, again, just straight up use Anaconda, the Python version that is in there. I think they're a little behind. I think they're on 3.6 if I remember correctly, whereas vanilla Python's on 3.8. Oh, hey, they're on 3.7. Cool, they've updated. I won't do the whole installation. I will tell you that anywhere it says Python 2.7, avoid that like the plague as best as you can. Python 2, they dropped support like a month ago, so it's like you can still find that people are using the code, but like it is not technically in active development anymore. And 3 is definitely the way to go. 3.6 introduced some cool stuff like static typing. 3.7, or is it 3.7? I can't remember. 3.8, the bigger changes where there's security stuff under the hood. And I think there's better support for typing, if I remember correctly. And that's all technical jargon. I actually have, oh, let me actually put this link in the chat so it's more useful. And the chat window is all the way over here. Cool. Oh no. Okay, yeah. So if you want to play with Python stuff or data science in general, that's the link you want to go to. It's Anaconda. Pick it for your platform. If you are one of the people who is running Windows subsystem for Linux on Windows 10, you do not want to install the. You know what? I take that back. If you're running Windows subsystem for Linux on Windows 10 and you want Python stuff, you might actually install both versions. You might install, if I remember correctly, I installed Linux on the Windows subsystem for Linux, and I installed the Windows version on the actual Windows installation. And the reason why is because there's some features through Windows subsystem for Linux that are disabled. So things like external GPU support, if you want to actually train machine learning models on that, if you try to call that in Linux, it will actually say this feature is not supported. So that is something that I think Microsoft has to work on. And if they did enable something like that, that would probably give them a lot of competition for their own operating system. So I'm not sure if that would be introduced. But that way, what you can do is you can write all of your code and do the basic stuff in Linux. And then when it's time to actually train on something that's like hardcore, you can just run it in the Windows environment. That's fine. WSL, Windows Subsystem for Linux, it basically, it's not a separate install. It's not like Boot Camp for Mac. So it's actually pretty cool technology. It's like a really good virtual machine, and it dynamically allocates memory and all that. It's a lot less complicated. What I can do is actually I can show you. I wrote articles on how to get these things working. They were published by Analytics Vidya, and I had one that I did not elect to send to Analytics Vidya because it wasn't really data science. It was more technical stuff on like how to get how to get Docker working, which has some similar stuff in it. Let me see if I can remember the. If I go to my author. Yeah, here we go. This is my page, and all the stories I've published. Go. Give me a follow there if you've never seen, if you think this stuff would be helpful. But basically, this how to Docker on Windows 10 Home with Subsystem for Linux 2. That's actually pretty useful. Because if you're running Windows 10 Home like I am on my Dell, there is a complication because there's like a feature that a virtual machine depends on that is both enabled and disabled by default in Windows 10 Home. So follow those if you want to actually get this working to get Linux and stuff on your computer, on your Windows 10. And the other thing that would be good to talk about is the static typing. So because I've mentioned it kind of a few times already, programming has typing, basically like any variable you create. Some languages like Java, it's static typing, so you have to also declare what the data type is. Python doesn't have that. You can just say like x equals something, and we'll just assign a data type to x. Sometimes it's really good. I think it speeds things up so you don't have to type int or whatever data structure that you want all the time. But other times it can be annoying. So that article, the static and dynamic typing, does a better breakdown of that kind of stuff. So yeah. Okay, so we've got the link to Anaconda and we've got the link to some explanatory articles. So right now, I will tell you that one reason why to use Anaconda is because it actually comes with Jupyter. So we have got the data downloaded, and we're gonna finish out this markdown before I forget. So what is this project? This repo is the initial date with data and explores the data set provided in a Kaggle repo. Let me actually swap back to Visual Studio Code. So we're going to turn off Brave and turn back Visual Studio Code. Provided in a Kaggle, I guess it's a repo. I forgot what it's called. Kaggle. Yeah, let's just say repo. This repo is the initial date with data. So today is 2020-04-29, and explores the data set provided in a Kaggle repo. The Kaggle information is here, and then I'm going to copy and paste the URL. And because it's Markdown, I can do Markdown fanciness. So that would be this. And basically what that's going to make in the Markdown is that this is going to be a clickable link. Kaggle information's here. But the gist of the repo data set is that this is a CSV containing base stats, types, and indices, and Pokedex. Man, I am typing very poorly today. Pokedex indices for all 781 Pokemon, I think they said. Let's see. Now, what is this project? What is this repo? Requirements. I will actually, so when you install Anaconda, it comes with a base virtual environment. And what that means for Anaconda, and I think also pip, is that it comes pre-installed with a bunch of libraries and stuff ready. So one reason why I like Anaconda, actually kind of a pro and con of using Anaconda is if you use the base repo, it comes with so much stuff pre-installed that you might not actually need it. So in this case, it's actually fairly useful because the things that I would like to use to explain what's going on and do the exploratory data analysis or EDA is all stuff that is already pre-installed. So it's things like Jupyter notebooks, Jupyter in the back end, and then all the WebSocket stuff to get Jupyter to work. It'll come with NumPy and Pandas, and it'll come with, let me think of what else. We'll worry about that later. But basically what I'm going to do in Terminal, since I know you can't see it, I'm going to actually copy the base virtual environment and then make it a new one called Pokemon. So we're going to do conda create and dash name, and it's going to be Pokemon Kaggle, and I believe it's copy. Could we dash copy? Let's go look. So I'm going to turn off Visual Studio Code again and turn on Brave. Here we go. It'll work. There we go. Okay, turn on Brave. So since we are using Anaconda, we can look up all the Anaconda commands. So conda, I always do managing conda environments. There's a type. Cool. What we've got here is, let's make this window bigger. Yeah, and if you're watching, you've got more experience working with data or data science, and you want to say something, like, feel free. I'm curious, like, hey, am I doing stuff right? Am I doing stuff wrong? Et cetera, et cetera. But what I'm going to do is I honestly, I do this for every project. So I make a Git repo for each project, and I make a virtual environment for each one because each one can require different stuff, and it gets really complicated if you're in the base environment and you keep adding stuff to it and not using some of it. When I was working on Melion, which is my independent project, and I'm still working on it, I quickly discovered that when I tried to deploy to Heroku, which is a web serving platform for this kind of stuff, there's a free tier, but the free tier is like, I don't know, they run it on like a potato and like a shoestring. I'm not really sure, but it's like super slow and it has very limited memory. So when I sent my like normal environment that had everything kind of all put together, it was basically the base conda environment adding a bunch of stuff. It ran out the memory. I'd say like 80% of the time someone tried to do a query, and that was bad. So what I ended up doing was I made a whole separate a whole separate conda environment that just had the stuff that I needed to get working in Heroku, or in Melion. So I disabled things like it didn't need let me think. I didn't need Jupyter, it turns out, because like the exploratory data analysis, I could just do with the base repo, and then I could just like swap different environments. Um, but when I got it working, I had like maybe only 10 or 12 libraries installed for Melion, and it was just very aggressive, like cutting back on things I wasn't using. So, excuse me. In this case, I want to create a virtual environment that is exactly the same as the base environment because I think it's safe enough to do that. And I honestly don't know what kind of stuff I'm going to need to do it. I just don't want to add bloat to the base environment in case I want to do other projects that use the base. So the other reason why I'm doing it this way is because during the uh, during my boot camp, it was a great experience. But one of the things that I had a problem with was trying to work with TensorFlow. Um, there's like one day where I needed two different versions of TensorFlow, and when I swapped between them, it kind of broke stuff I was doing. So if I just made a separate environment for like this, like for like that part of the day versus the second part of the day, it probably would have worked fine. So that taught me a lesson of like, oh, just make a separate repo for each project that you're trying to do. Okay, so here we got clearing environment. Um, we're going to use the terminal again, which you can't see. I don't know why that's not working, but the command is conda create dash dash name, and then the name of the actual thing that I want to create, and then it is dash dash clone, um, and then the name of the environment that I'm cloning. So I was pretty close. I had written conda create env. That part was wrong. I didn't need to do that. Conda create dash dash name, and I wrote Pokemon Kaggle, and then I just need to put dash dash clone, and I'm gonna say base. And it's going to ask if I want to create it in this directory once it speeds up a little bit. Cool. So it said source, Anaconda folder, and then destination, the environments, and it's going to be called Pokemon Kaggle. It is still working. I'm just using too much CPU right now, so I'm going to do like a chair dance and entertain myself. But we are, let's see, we've got the managing environment command down, and we have that ready to go. As soon as this gets cloned over, then we can get back to working, and I will open a Jupyter notebook, and then we can see the actual thing. Just to be advanced, I'm going to open another tab, and then this one is going to be the actual. In Python, we're going to have to import CSV. I know that because we need to actually handle CSVs. And then the other thing we have to do is get ready to, let's see, I need the actual command. So it's like with open CSV Python. And it's just all these things that like you kind of remember, and then like once or twice get your project working, and then you're working on this project, it's like, oh, cool. How do you do that again? So here's an example. We've got import CSV, which we're going to have to do, and then with open. So in this case, it would be replaced with the name of Pokemon CSV. I actually don't think we need the new line identifier thing, but I don't remember what was in this CSV. And then basically just load it in. But since we were using pandas, because I think it's just easier to do it that way, we can actually just use the pandas way of dealing with CSVs. So this actually is kind of, it's still, the computer is still cloning over the environment. This actually maybe a good time for a discussion point. I saw an interesting post in R Data Science, the subreddit for data science, or I think it was maybe Learn Python, but they were arguing that for teaching data science, when you do an import of a CSV, using pandas to do it was actually not a great idea. And their reasoning was because for a complete newbie to programming, having library that doesn't explain what it's doing, but just kind of does magic, and then the thing works to make a pandas data frame. Uh, that's weird, right? Because like you've barely, you've probably barely like actually gotten familiar with it, and if you're working with Jupyter, like you're kind of like jumping straight off the deep end. So as someone who's practical, uh, I think that pandas data frames are the way to go. But I actually kind of agree with that statement because like how you can actually display like maybe the columns or the header of the data frame from the CSV is you can actually open it in just straight up Python, like, and you can just have it print the first couple lines and just say like, you know, here's your if it's a CSV, do a split for the columns on commas or tabs or whatever it is, and then just print out the first 5 lines, right? So that actually is good experience, I think. And it would actually in terminal in your command prompt, it would show that. In a Jupyter notebook, it would also print it as well. And I think that's good for doing some sort of like very initial data exploration where you just want to see, say, like what the columns are. But to do any sort of manipulation, it is better, I think, to do it with pandas because like you don't have to deal with the trying to call different indices here. You can, if you want to, you can put all this into a list of lists that has everything, which I have a feeling that's what Pandas is doing in the background. Maybe not. I mean, Pandas is using NumPy arrays. All right. So this is a whole separate thing. But yeah, if you're just learning how to program this stuff, I could see the argument of like, why don't we do this like very basic thing? But if you are going to do more data sciencey things, it's probably better to do it in Pandas, just because it gets you into the workflow that people are using. Yeah, I guess similar argument for R. Um, R is really good at statistics and generating visualizations for statistics, but then when you want to do more advanced stuff, like there's just so many more libraries in Python. It's like you just do it in Python. And that's a hot take. People who love R like really love R, and it is really nice. I liked it, but when I'm trying to mix Python with it, it just made things more complicated. Cool. So the conda environment has finally cloned over. So what we're going to do is do conda in the command line or in terminal. Conda activates. I called it Pokemon Kaggle. And now I've activated it. In terminal, it actually displays that I am using the conda environment Pokemon Kaggle. And we want to run a Jupyter notebook. So we're going to say Jupyter. And I'm just going to write Jupyter notebook and hit enter. And that should start up the server for the Jupyter notebook. And looks like it is working, and it gave a link. And I'm going to copy and paste this into the browser. Or try to. Cool. All right, cool. All right, so we got it working. What we're going to do here is I'm just going to make a notebook file with Python 3. And here we go. Okay. Um, we have the markdown to explain everything. So I'm just going to start putting stuff in here. So things that we need import CSV. Let me actually I'm going to split this cell. So say import, change this into a, I remember the shortcuts, but I'm realizing like that's not great to see. So what I'm going to do is I'm going to actually use the drop down menus and stuff. Let me actually make this bigger to make it a little easier to read. Okay, so let me start over. Like I split a cell and it looked like magic because I didn't actually explain what I was doing. So what I've got right now is I've got a cell that can run code. For my first cell, I actually want it to essentially just be markdown because I want to explain like what am I doing in this first step. Well, I'm going to make this a header. Let's make it a second level. Well, let's put a title on this thing, right? So date with data 2020 04.29, and this is Pokemon, let's say exploratory data analysis with Pokemon CSV. With Kaggle Pokemon CSV. So here, when I hit Shift Enter, what it's going to do is it's going to render that cell. So you can see it's like now the head thing. Whoops, hit that paragraph button accident. So this is a little too big in my opinion. So I'm going to do this and then author Aaron W. Chen, and I'll put I think later. Whoa, okay, didn't mean to do that. So yeah, that rendered everything out. And then in the first step, what I'm going to do, I'm going to turn this back into a markdown cell. Back to a markdown cell. I'm going to say, split that, markdown, and do a second level header, import necessary libraries. I kind of like doing this as I'm working, trying to split it into sections and trying to explain what each section is trying to do, just to make things really clear so that when you try to read it later, it makes more sense. So we got import CSV because we have a CSV that we have to deal with. Import pandas, which is already installed because it's from the cloning of the base repo. So in addition to importing pandas, I'm actually going to rename it something else because if I just import pandas, every time I try to call something from pandas, I'm going to have to write out pandas. So I'm going to say import pandas as PD. And then I'm pretty sure we're going to need NumPy. So just in case, import NumPy as NP. Why these two? It's because they're kind of standardized already. People have like been doing this stuff for a while, and those are the abbreviations that they've picked. What else do we need? We're going to do some visualization, some plotting. So we're going to say import matplotlib as pyplot. I believe that's the right one. Oh, wow. It's been a while since I've done the visualization. So I'm going to open a new tab in Terminal, and I'm going to tell Conda to tell me what all the packages I've got installed are. So cd back into the project directory. And it's going to be Kaggle and ls cd Pokemon, and we're going to Conda activate. Oh wait, it's the same as the base environment. So Conda list env, not env, just Conda list. When you do Conda list in the terminal, it will tell you all the packages that are installed. And let's see what we got here. It's going to be a little slow. Cool. It is called Matplotlib. Okay. Cool. So I didn't forget that part. All right, so we're going to import Matplotlib as pyplot, and then we're also going to do this magic command, plotlib inline, and that should make it. I've been told that this makes it so that they render in the cells correctly. If we hit Shift Enter, it's going to do all of that, do all the importing, and it should be ready soon. So when the star becomes, when the asterisk 1, oh yeah, asterisk, star, or splat. There's context for all of those. Um, dang. Okay. Well, whatever. Anyway, it finished, so it says it's ready to go. So what we can do now is I'm going to split this into. Whoops. Turn this into Markdown. Take a sip of water. And what we're going to do is basically we're just going to open this pandas data frame. We're going to open the CSV as a pandas data frame. So here I've got the documentation for opening it with straight Python using the CSV library, but we're not going to say pandas documentation open CSV because we want it to go straight into a pandas data frame. And normally I would just write these things out, but because and I don't know the experience level of people involved, I think it's better to just kind of show you the stuff that we're going through and realize that, like, hey, it's okay if you don't remember the exact thing. Honestly, that's also part of the reason why I don't remember all of the exact commands all the time. But it's really easy to figure it out. So, like, pandas read CSV, it's really easy. In our case, because we shortened pandas, it's going to be pd.readcsv. There's a whole bunch of stuff that you can deal with in terms of what things you want to worry about. So if you've got numbers in there, like you've got thousand separators in case like you're from, I think my friend from Turkey, they said that like thousands are denoted with decimals instead of or periods instead of commas, like in the U.S. So what we're gonna do is just a real simple pd.read_csv. Oh, also we're gonna save this. So Pokemon Kaggle EDA, and we're gonna say df equals pd.read_csv, and then it was called well, let's add a cell above this. So we're gonna go cell above, insert cell above, and just to do this, show this trick. So I'm going to do bang or exclamation mark, and we'll just do ls. And what this does is it basically turns into a terminal command. So this tells us that it's just called Pokemon.csv. And then we're going to do df.head, which will show the top 5. Cool. So we have got, oh, this is going to be interesting. So I'll explain what's going on here. On the very left-hand side is the actual df index. And then it treated the initial column, which was the Pokedex entry, as a separate data column. So there are two options here. I could actually force this Pokedex entry column to be the index if I really wanted to. Personally, I think I'd probably do that because like it doesn't make a whole lot of sense to have a Pokemon 0 because, I mean, take out your game, take out Pokemon Go, take out whatever, like there is no 0 Pokemon. And technically this index is already provided for us, and now we're just making the data set more complicated. And then what we've got here, oh, you know what? I take that back. Wow, I completely forgot. Okay, so if we go on further, when we go to the name, we see Bulbasaur, Ivysaur, Venusaur. And I don't know how up to date you are on Pokemon, but starting with, I think it was Black White, or is it XY? They introduced this, like, in my opinion, completely underutilized game mechanic called Mega Evolutions. And not all Pokemon have it. Some have this form called Mega Evolution, which only happens inside battle. And now they've added this other thing called like Gigantamax or something like that. So now I realize actually probably can't use the Pokedex entry as the actual index because this is unique, the pandas data frame assigned values, but the Pokedex entries are not because the Mega Evolutions, for example, and also the Gigantamax forms don't have separate Pokedex entries. They're just part of that Pokemon. So if we were to swap into using this as the data frame entry, that would actually cause a huge problem. Yeah, and now because you'd have non-unique indices, which would, yeah, that's not good for later on. So I guess we're just going to keep this column of pandas assigned indices, and then from here we can actually see uh, all of the other different columns. So yeah, and it's all laid out just like in that Explorer on Kaggle. So it's good that that's working. And you can see Charmander is only one type. It is a fire type and then not another type. So everything, all the other Pokemon that are single typed or monotyped, they're going to have this Nan. Normally, so let's say we do df dot describe, this would tell us some statistical on the actual data frame. So what we've got 800 entries in terms of inside the numbers. I wish it would actually. I'll type this out right here too. But if we do df.shape, I have a feeling that 800 is not going to be the same. Oh, it is the same. Okay, so it's just counting if we do. Let's say we do df dot unique. df ampersand dot unique. Yeah. Okay. So what I've done here is I've said go to this data frame df that we made. Go to the column that is titled ampersand, which is this one, and then give me back all the unique ones. So all it really did is give me a number from 1 to 721. So if we do df.unique.counts, or let's see, unique, I think it's just unique counts. Okay, well, another thing that's good about Jupyter is if you think you know what the command is, you can actually shift tab, I believe. Oh, it's not working. Let's this. Yeah, and you are gonna want at it's gonna load a little bit. That would be useful. And indexing and iteration, binary operator functions. Okay, so we just want to find the uniques. And more importantly, we just want a count of the uniques. Here we go. Count distinct observations of requested axis. Is there another one? There is not. Okay, so we're just non-unique. Like that. And let's see. I may have not called it correctly. And I definitely opened the inspector in Brave. That was a mistake. Close it away because it's totally unnecessary. Yeah, so I'm thinking of doing something like this, like every 2 weeks, or not every 2 weeks, maybe every week. Part of the reason why I want to do this is that I think it's fun to teach people this stuff, and also I think that one of the things about data science that I've noticed is like there's a lot of just pre-work. So like I set up a bunch of time this time just finding a data set, right? Like, and then explaining what we're gonna try to do with it. If I'd picked a more complicated thing like bird species thing, I'm sure that's gonna take just as much time to set up. But later on, where these differ is that the Pokemon one, I could probably finish exploring this data set pretty quickly, just because not a whole lot. But if I were to try to train a model on this bird species one, it's going to take a lot longer. And for the purposes of a stream, I don't think that's all that fun, right? Like, how much have you just sat here watching me read stuff? So, yeah, this I want to keep going as like a series, and we can do some more exploration, especially when we get more complicated stuff. What I can try to do when it gets more complicated is just lay out the workflow, the thought process behind doing stuff, and then basically at the end of the stream, just run the model, and then the next time we can actually see what the results are. Or if it requires a lot of iteration, I'll just run it like without people watching, and then show and talk about like what the differences were in between stream sessions. Um, so in this case, like yeah. Okay. Cool. Cool. So it finished running. In this case, we're just doing some real basic exploratory data analysis. I think like I'm not honestly not even sure what kind of stuff I want to do with this data set now that I think about it. I could double check to make sure that the total stat is actually correct because like if that weren't correct, that would be a huge problem, right? So like that's a kind of basic fact checking thing of like, is it doing what it says it's supposed to be doing? If not, then we could actually try to do like a pull request and say like, hey, there's a bug somewhere in here. Um, and then in here in type one and type two, I guess what we could try to do is we could try to combine this with the type chart and just try to say like, grass is really good against water and is weak to fire. So we could try to say, given we've got, say, Bulbasaur, what Pokemon would I be in a favorable matchup with versus a unfavorable matchup? Not factoring in moves, just the types. And because there's a whole rock paper scissors thing, it's like kind of interesting. Like I think people don't realize this because Generation One was actually kind of messed up in terms of the Pokemon typing, but like grass is actually weak to poison. um, so this combination of grass poison introduced some complexity in terms of like how different types played against each other. So like poison is weak to ground, but grass is not. So I think those actually canceled out against grass poison Pokemon. And then the other thing is that there are very few pure grass Pokemon in Generation One. So it ends up becoming like a weird combination of like, well, we set all these rules for typing, and then we basically don't have anything that follows those rules. Yeah. Sorry, my inner Pokemon nerd is coming out. I don't know if you noticed. But yeah, basically what we did with this df number dot unique is showed that like even though there are 800 entries, as you can see here, there's 800 entries total, there are actually only 721 Pokemon. So there's some combination of like maybe these are megaforms, maybe they're Gigantamax, maybe they're Alolan. So I guess what I'll write down is I'm going to run this in Markdown cell. And what I'm going to do now is I only wanted to do this for about 2 hours time, just because it's also during dinner time and I'm starting to get hungry. What I'm going to do now is basically I'm going to write down all the things that we did this time, and then write down all the things that we want to do to either get ready for next time or just do next time. So in this case, I'm going to make a markdown cell and split this. And what we did this time, more markdown. What we did on 2020.04.29, we did initial data set finding on Kaggle. And then we did, we did a very rudimentary introduction to setting up a data science environment. If you want more resources on these sorts of things, I can actually update with links to tutorials. So if you didn't have that stuff set up and you want to check this stuff out, and I think the stream gets recorded at least on YouTube. So like this, I can actually just put this in here and maybe put it in the links in the comments to install Anaconda. And I use Windows, so I would say Anaconda for Windows and Windows subsystem for Linux. What else did we do today? We started writing a markdown. Began writing a markdown README file for repo. We actually we did a git init, so we actually technically can have a GitHub repository for this. Created git repo, and then to do, I guess it'd be like link to GitHub. So that'd be interesting because all this stuff would be in there publicly. Okay. So we began writing the README for the repo. Began exploratory data analysis, EDA, with Jupyter Notebook. This notebook. So things we noticed. So we noticed that there are only 721 unique Pokédex entries, but there are 800 Pokemon. Why? In this case, since we have a resident Pokemon, we'll say expert, but I'll also admit it's nerd. So since we got someone who has played Pokemon and is a little bit more familiar with it, we know that the reason why is because there are duplicate entries due to alternate forms of Pokemon. These include Mega Evolutions, but may also have Alolan, Galarian, if this thing is really up to date, and Gigantamax. I think it's Gigantamax. I don't play the new Pokemon, and apparently there's a difference between just like a big version of the Pokemon and like a Gigantamax version. Gigantamax versions. What else? Other stuff we noticed. There are going to be nan or null values for the second type for some/many Pokemon. How to handle the null values? That's a question that we haven't answered yet. In this case, let me see. In this case, we might be able to drop them. Sorry, might be able to ignore them, but it depends on the use case for the data. In other cases where there's null values, like this could be a huge problem. Like do we just drop all null values if we don't have something like, oh, I don't know. If we don't have, if you're looking at like location data and you're missing latitude for some strange reason, right? Is that important? Well, do you have, if you have, is it real estate stuff? Like, is it housing related? Do you have an address instead that could make up for it? Can it be repopulated? In that case, like, if you're going to, oh, I forgot what the word is. If you're going to augment the data with something that you have to plug in to replace something, like then it's like, oh, we'll just make a separate column to, and note that it is actually not raw data. In this case, or sometimes you can just drop the record that has the null information. Here, that would actually be a really bad idea because if you dropped anything that had a null for the second type, you would drop a bunch of Pokemon, and then you would have a very incomplete Pokedex. So yeah, what else? We also need to deal with, oops. Oh yeah, we noticed the sum of stats, but are not yet sure if that is correct. So here, suggest doing a simple sum of the stats in a new column to see whether or not the reported / given sum of stats column is correct. If not correct, see if we can do a pull request to update the source data so that it is fixed. I have a feeling that it's fine. A lot of people have looked at this data, but again, it's good to be sure. Let's see. For next time, what do we want to do with this data? Let's say we want to suggest ideal, favorable, unfavorable typing or matchups based on typing. Do we want to suggest favorable match, favorable, unfavorable match, match ups based on stats, right? So like one example would be Rattata is a normal type and is one of the weaker ones in the game. So if you wanted to do a comparison, let's see. That's actually a bad example because it's a normal type. Let's go with Pidgey, right? Pidgey is both normal and flying, but the flying type is important because it has better matchups. It is favorable against certain types like grass, bug, and fighting. So if we wanted to do a comparison of like, okay, what's a favorable type for Pidgey just based off of typing, it would suggest something like, okay, well, you should be okay against a Machamp, which is obviously wrong. The reason why is because Pidgey is like really, really weak and very fragile, and Machamp is incredibly strong and also kind of fragile. But in a straight up one-to-one fight between a Pidgey and a Machamp, even though the Pidgey has the better typing and should win based off of that, the stat difference is so big that it would very likely lose any sort of matchup. So we could also do a suggest favorable, unfavorable matchup based on the stats too, or filter the matchups, or filter matchups based on typing and stat criteria. Notice that this doesn't incorporate moves. That would actually be really hard. So this already is actually like, oh, cool. Maybe we could get something out of this. Yeah, so that's what we did this time. And then what I'm going to do is for next time, you know what? This might be good to show. Uh, I should consider walk through setting up the GitHub repo for this because I didn't do a walkthrough of like setting up the development environment, and that is actually kind of complicated. But setting up the GitHub repo shouldn't be too bad. Although one potential hiccup, terminal not does not show on in stream. So that's a bit of a problem. So admin stuff for me to figure out is like, why doesn't terminal show up in stream? Yeah, but I think that yeah. Sorry, I showed up like a little late. I showered before the workout, but this is about like I wanted to do about 6 to 8 p.m. And we're running a little bit over, but I was like 20 minutes late. But I think that this is a pretty good thing that we can try. In terms of the long term for this notebook, like I don't think this is a great way to present the data very quickly. If I keep doing these like workflow things like this, it's going to be bad. So what I'm going to do actually is this whole cell that has like what we did today and what we can do next time, I am going to cut this and we're going to go back to Visual Studio Code once I turn off Brave. And we're going to actually put this in here. And then that is a little bit better because it helps clean up that notebook. So we can actually just leave that for the data analysis, exploratory data analysis. Notice that we have not finished this part. So we need to write the requirements. Did I not spell that correctly? Okay, requirements. Let's see. We're going to need Anaconda. Or let's say Python via Anaconda is the easiest way to do this. And we're going to paste all of that stuff that we did in the markdown cell. So this is what we did. And then things we noticed, and then for next time. And what we can also do is, let's see. Oh, generate a requirements.txt. Not all caps. It doesn't have to be all shouty. Requirements txt or a what's it called? YAML. Conda prefers YAML. And requirements.txt is for pip, which 6 of one, half does the other sort of thing. Even though we're using pip, even though we're using Conda right now, pip would still, you can still pip install stuff and it works fine. Generate a requirements.txt or YAML and upload to GitHub repo. So yeah, let me get some more water. Maybe this will actually be a bit longer than expected in terms of working with this data set. Yeah, like I said, my brother and I, we're trying to work out like just for a side project for fun. We think it'd be cool to actually build like a machine learning algorithm that can help you create a Pokemon team. Yeah, it's nerdy. It's fine. I think it's cool. It's a good project, and because it's actually really complicated, it could present a good opportunity to work with more advanced packages. So I think that might actually be a good way to use like TensorFlow. And the reason why I bring this up is because I had a mentor that was in the. Let me try to move this mic up. There we go. I had a mentor that was in the. Oh, I'm gonna need a screwdriver. Okay. I had a mentor from the puppy community, which sounds weird. It's short for Puget Sound Python programmers community, I believe. And he was explaining that when he was kind of like looking for an independent project to do, he played a lot of Magic: The Gathering. So he built a deck builder using PyTorch to try to optimize like the how the deck could play. And I thought it was really cool. I was pretty inspired. I was like, oh, you know what? Like people really love Pokemon. Like if you look online and try to find like PvP stuff on Pokemon where players play against other players instead of the collecting and exploring part of the game, that gets very serious and very competitive. So it'd be cool, I think, to build a AI that would actually help you build a team, and then determine like, hey, like what are the odds that you're going to play against, or how well will you do against like certain other teams? Could even turn that into a generative adversarial network and say like, well, I built this team this time. Why don't I build a team that would beat this team? You know. So I don't know. I think it'd be cool. I'd learn a lot just by doing that. So I'm kind of looking forward to trying that at least. But yeah, I think I'm gonna call it for now. If you have any questions, like feel free to message me. My contact information should be visible in the stream. My Instagram, my Twitch, Facebook, YouTube. My Medium, as you can see in the links, is right there. And there's also my GitHub, which I will put up in the stream later, I think. Yeah, feel free to message me if you have any feedback, suggestions, or other things you want to see. I'm looking forward to hearing from you, and I hope that all of you have I guess like a great day. I actually have to swap. This is gonna be real fancy. Oh wait, no, I can just end the stream from here. Sorry, I'm streaming technically outputting everything from my laptop and then sending it to my desktop, which is underneath, and then having that stream. But I guess I could technically just turn this off. So actually, why don't I just? I think I think that's right. Yeah, yeah. Okay, cool. All right. Hope to hear from y'all soon. And yeah, till next week or maybe Sunday when I try to do my art streams. And that's just photo editing stuff and story time. So yeah, cool. All right. See you later. Bye.